This week's project began with a simple task. Make a laser engraver using our very versatile CD-ROM drive CNC machine platform. In theory, it seems like a straightforward task. Not so much. You could go out and buy a burning laser with a heat sink, laser drive, and power supply, strap it to the CD-ROM drive CNC machine, and there you go. But that's not how we do things around here. The knowledge and experience gained through making something is much more valuable than just throwing money at it. At least that's what I keep telling myself. Alright, let's sketch. The idea here is to scavenge a laser from one of our CD-DVD drives that we tore apart to make our CNC machine, and then use it to cut or engrave materials. After extracting it, we'll need to create a laser driver for it, an adjustable lens to focus the laser, and then a switching mechanism that allows us to turn it on and off using our Arduino. Okay, first things first, scavenging the laser diode. It's hard to show exact steps for this method because every optical drive is different, but basically what you want to do is strip the drive components down to this carriage slider. Housed inside of this hunk of plastic is lenses, mirrors, and a laser. Generally, it's somewhere on the side with 3 prongs soldered to a circuit ribbon. Be careful in removing anything fastening it to the carriage and then carefully remove it. And I say careful because this was my second attempt at a successful recovery. Sometimes you'll get a laser diode that looks round like this one, and here are the power pinouts for it. And then others will be flat like this, and then here are the power pinouts for it. Solder a wire to the ground wire and one to the positive wire, and then we need to secure it in a casing with an adjustable focus lens. You could order laser housings online, but you may have something lying around the house that you could scavenge, such as this laser parking assistant that I got for the holidays. It has a laser housing as well as a screw-on adjustable lens. I'll set the lens focus before securing it in the housing. So next we need a way to power it. Here's a breakdown of some of the different optical drive lasers. As you can see, without the right tools, guessing what type of laser you have isn't an easy task. And thus begins the source of all my frustrations. So to power the laser without frying it, we need to create a laser driver, which revolves around this, the LM317 voltage regulator, which outputs a fixed voltage. Adding resistors to the middle pin can adjust it to a more precise voltage. If you're testing out multiple laser power settings, you could even add a variable resistor for easier adjusting. Then you want to add a diode to make sure the current only flows in one direction, and a 10 UF capacitor to ensure a constant current. Connect the power here and the ground here, and then connect the laser to this positive and negative side. Before testing your laser out, please read this Wikipedia article on laser safety, and at the very least, get a good pair of laser goggles and don't shine the laser into your eyes. Before we jump off the breadboard, let's add a way to switch this circuit on and off through an Arduino. For the 3D printer video, we used a transistor as a switch, so this time I'll show you how to do it with a relay. One side of the relay is to split the positive wire into 2 different pins. This keeps them unconnected until current is applied to these 2 pins, which we send to the ground and 12 pins on the Arduino. Now when the 12 pin is enabled, it should switch the laser on. At this point, you should be able to tweak the laser focus lens and variable resistance until you get it to burn a piece of paper. However, I couldn't get mine to work. I believe it was due to the scavenged focus lens that I was using not being strong enough, or it could possibly be that I damaged the laser diode. But these are the steps to follow to make your own laser work. Truth be told though, the amount of time and effort to scavenge and reuse a laser diode was frustrating, confusing, inconsistent, and not worth it. So I caved in and bought this, a $42 405 nanometer burning laser. All you have to do is plug it in and adjust the focus or depth. So much easier. Since it has its own laser driver built in, all I had to do was rig it up to the relay somewhere between the power and the laser so that I could control it with Arduino. I mounted my laser to the Z-axis, but to be honest, you don't even really need the Z-axis at all. You could just mount the laser directly to the X-axis. So for those of you that only have 2 CD-ROM drives that you can use for this project, you can still make one of these laser engravers. Now on to the G-code side. You can follow the steps from my previous tutorials for going to makercam.com and creating or importing a design, and then in the follow path operations, set the target depth to -1, safety height to 1, stock surface to 0, and the step down to 1. The feed rate is the speed at which the laser will move, and we want it to move slow enough to burn our item. So I set mine all the way down to 8, but your results may vary. Plunge rate doesn't matter, so then just click OK, calculate it, and export it to G-code. Similar to my 3D printer video, we'll need to tweak this code a little bit to get it to work. Change the -1Z movement to the height at which the laser burns best. For me, it was between 5 and 6 on the Z-axis. Move the M3 value to start the laser after the Z-axis movement, then skip to the bottom of the file, move the M5 value up to here to cut the laser off, and then move the axes back to their home positions. Save it and open up Gerbil Controller, connect your Arduino, and power on your CNC machine and laser. Load up your saved image and then click Begin. If everything works well, the laser should start engraving your item. I'm using a couple of post-it notes on top of the circuit board, and as you can see, the laser was enough to cut through the paper. This was a tough project for me, but let me know if you guys have more successful stories. What ideas would you like me to cover next? Submit or vote for your favorites at tinkernut.com/ideas. Click here to watch my last video, and if you'd like to support my show, please feel free to subscribe, comment, follow me on social media, or donate at tinkernut.com/donate. Alright, that's it for this tutorial. For more, go to tinkernut.com.